Hello and welcome to the introduction video to our Twitter analyzer app. Our program is composed of 6 main menus called credentials, collector, detector, analyzer, visualizer, and streamer. And in this video I'm gonna walk you through different menus and show you different jobs which can be run in each of these menus. So here's the main interface of our program. It's basically covering two main aspects of working with social media: collecting the content communicated over social media and collecting information on users who are communicating with each other over social network and social media. But mainly this platform is designed to work with Twitter, and in order to work with Twitter, the first thing which is required is a set of credentials for authentications when communicating with Twitter API. The main menu of the program gets us into the sets of credentials created and which can be used in the program while sending different requests to Twitter. This example, which is shown right now, has 3 sets of credentials. In order to create these credentials, the user must go to Twitter developers first, which is here, and then you can create new apps under your Twitter ID. Once you click in, there are a set of informations asked for, including name and other information, and then a little description about the app that you're creating, which is not really important. And bam, you create your Twitter application. And this Twitter application, if I get back to one of the applications that I have created, gives the user a set of information which are used for authentication. Particularly, the key and access tokens are the ones which are needed to be used in our program. Once you come into keys and access tokens, there are 4 major the strings which are needed from here to be copied. The first one is the consumer key. As you see, the consumer key is a string. The second one is a consumer secret or API secret. And then the other 2 are access tokens and access token secrets. So these 4 strings are needed to send any type of request on behalf of yours to Twitter API. So if I get back into the main program, here is where all the credentials are kept and handled and managed. If you want to add the new credentials that you just created, you just need to click on that key, and here the 4 keys that I just explained are, it's just a matter of copy paste, and once you add them, they would be added to the collection of credentials which are available for use. If you make any mistake or you enter incorrect credentials, I'm just putting some random credentials set, then if you try to add, you get this message of invalid or expired token. So the token needs to be valid for us to begin. So once these credentials and more are available, then our program can assign them to any data collection activity or data collection job. Our program has the capability of optimizing use of credentials and sending parallel requests with multiple credentials. Well, basically all is needed is to add the new credentials here, and different menus of the program will get into this part and will use the set of authentication sets for communicating with Twitter API. Well, the first thing to do with using these credentials is what is collected under the menu called streamer. When I come into this menu, this is the main menu used for collecting tweets which are using a certain keyword like hashtags or mentioning stuff like that. In order to start a new streamer job, just click on that button, and then all is needed is a keyword. Let's say bus is what I'm looking for. If I'm looking for multiple keywords, I can add them. They're comma separated. So let's say bus, transit, and city. And yeah, let's say I'm looking for these 3, and I just submit the 3. the program automatically selects one set of credentials, assign it into this request, and as you see, it's ongoing right now. It shows me that it's ongoing. I can pause it if I want and continue. And at any certain moment, I can pause and export the results. It's showing me how many tweets are collected so far, and it shows me if it's still collecting or if it's stopped. So in this few seconds, we collected 138 tweets using these keywords. It's not surprising because they were kind of common words that we put in. And at any moment that I want, let's say I want to retrieve these 138 tweets, what I can do is to just pause it and export the results, which will be exported as a CSV file. Another alternative for exporting the results is through this menu up here, which allows me to export the tweets collected, and also it adds some filters. I can select which tweets within which time interval I'm looking for to be exported. And also the other thing is we can always add parallel streamers. Like let's say at the same time I want to add a new streamer collecting information on pipelines, for example, and I just submit it, and the third one and the fourth one, and so on and so forth, and they can work together at the same time. And again, the program has the capability of assigning proper set of credentials into each of these requests. So what happens is each of these streamer jobs are ongoing. What the program does is it keeps listening to the tweeter, and as soon as a new tweet is out there, which includes one of these keywords, it just adds it into the set of tweets that we had. It adds it into the database, and again, whenever we want, we can select the whole or part of that database and export it into a CSV file. So if I get back into the set of credentials, those credentials which are in use as shown here, this credential set is not available right now. It's assigned to one or some of the jobs which are ongoing, and shows me how many credential sets are available for other jobs in the platform. The second main menu of this platform is the collector menu, and in collector menu we collect general information about different user profiles and user IDs. So once I start a new collector job, there are three different options for me: getting tweets, which collects all the tweets by a certain Twitter ID, getting the followers, which returns back the full list of followers of any node that I select with a description of the followers, and getting user information, which returns back the general information of a user. So for example, to show you how it works, I start by getting user info for one of the projects that I've been focused on, the Eglinton Crosstown project. Crosstown TO is the Twitter ID for that project. Once I add it, as seen, it's pretty fast for such a job. It just completed collecting all the information about this project, and then I can export the information either as a text file or as a JSON file, and the result will look like so let's save it as a JSON, for example, and here is the way that the results look like. So as you see, the user ID, the Twitter ID of Crosstown is shown, the numerical ID, and then the screen name, which is Crosstown TO, and then the description which Crosstown TO has put in its profile is shown as a text, and this is pretty helpful and useful later on in profiling different communities for a network and stuff. Then it also gives me the extra information on number of followers. Right now is 3,155 followers, and number of friends, which are IDs, those IDs that Crosstown TO is following, 306, and number of tweets, the total number of tweets, which is 1,074. So as you see, these are the general information for a node that I could collect in a few seconds. If I go back to the collector job, there were two other options to get the tweets, which collects and returns all the tweets by certain followers, as long as the Twitter API API limitations are not hit, which is the most 3200 tweets by each node on Twitter. It's basically this 3200 is the limitation for this version of API. It may change in future, and also to get followers, I can get the multiple files, multiple mini reports like what I just showed for Crosstown Toronto, and each report is reflecting back on one of the Twitter followers of the node that I'm collecting information on. So all all that information is collected and stored in the database, which can be used later on for creating networks of followers. The next menu of the platform is called Detector, and this menu is designed to collect social networks formed on Twitter. The main social networks that we are interested in are ego-centered networks, which means networks formed around an ego, and the ego is normally Twitter accounts. In our case, we are interested in different projects, and for each project we focus on the Twitter account of that project. And what I want to do is I want to collect a social network composed of all followers of that project. If I start the new detector job, the first option which is given to me is to get followers of followers. If I go for that option, the social network which will be retrieved is basically a directed network composed of all followers of a node, and there would be a directed edge between two nodes showing that the first node or the tail is following the second node or the head. The second option, get mentions and retweets, forms another social network in which the social linkages are basically reflecting if two nodes have retweeted or mentioned each other. So basically, if node A has mentioned node B, then there would be an edge between A and B. And if A has mentioned B in 10 tweets, then the weight of that edge would be 10. On the other hand, if A has retweeted 5 tweets of B, there would be an edge going from A to B with weight of 5. So basically what we get in the second option for mentions and retweets will be a weighted directed graphs. And also there is this option here, which if I click, if I select, it gives me the full network. If I do not click this, the network which is collected is only a network of those nodes who are retweeting or mentioning the ego. But once I click and select this option, then the network which is created will be a full network of mentioning or retweeting among all followers of my project. Also, in collecting mentions and retweets, I am asked for the start and end date of the collection window or selection window. I can look for the network of retweets or mentioning among followers of a project between May and July of the last year, something like that. So in order to show how it works, let's start with the followers of followers, for example, and I just show you what we get when I select some sample, like myself, my own Twitter ID, Mazdak Nik, and so I put my user ID there, and it asks me to choose the file in which the answer will be stored, and I just create a new file. Let's say mazdaknik.txt, so it can be a text file, and I just add this job, and as you see, it starts, shows me as it completes. As I do not have too many followers, it didn't take that long. Sometimes for some huge networks it may take up to days or weeks to complete this job. Now the file is stored, and let me show you how the file looks like. This is an example of followers of followers network. It's basically a followership list. As you see in each row is highlighting an edge, and in each row I have two nodes, the source node and the target node. So for example, the first row shows this guy with this user ID on Twitter is following this person with this user ID, and all people that you see here are followers of my account, for example. On the other hand, the retweet mentioning output has extra entries in each row. In each row, after the source and target, as you see, there are a number of tweets mentioned and a number of retweets between the two nodes. So for example, the first row shows that the first person with this Twitter ID has mentioned the second person twice in the selection in the collection window that I selected, and has retweeted him only once within that period of time. Well, basically these inputs are used for visualizing the networks, as will happen in this menu. So in order to show the graphs formed out of these detectors, we need to come into this visualizer menu. And visualizing starts with by clicking on this button. As usual, it gives me two major options. Are you forming a network of followers, the directed network that I just talked about, or a mentioning / retweeting network, which is the directed weighted graphs that I explained earlier. So starting from, and also the mentioning retweet itself has two options. Is it a network of mentioning, or is it a network of retweeting? So I'll show you an example of how it works by showing you the mentioning network that I just formed. So it's a mentioning network. I selected the file, the text file is there, and all I need to do is to ask it to visualize. So here's the job completed, and then I click on view, and here's the network that I just explained. As you see, weighted edges, each edge is showing that the two nodes have been mentioned each other, and the node in yellow is our ego, the ego of our network, and the thicker lines show higher frequency of mentioning, the faint lines show lower frequency of mentioning. So here's the way that the network is visualized for mentioning or retweeting. However, to visualize the follower networks, some extra work is required. We need to go to Analyzer and do some analysis prior to being able to visualize it. When I add a new analysis job, these are the major options: the communities in the network and the network information, which is the general information of a network. I start with the community. It starts by selecting the file. The text file formed in the previous step from the detector will be selected here. And for community detection, two options are available. Two major algorithms in modularity maximization are available. And none of these two algorithms is a stable algorithm, which means each time that the algorithm is run with a different order of input file, slightly different answers will be resulted. In order to address this challenge, what we do is we run the program multiple times using each of these algorithms, and then we look at the best answers. So after selecting the file, the program is asking me for how many runs do you want me to go through and pick the best answer. So let's say I select I go for the best the best answer coming out with 10 runs, and then I analyze. And here is a short report on the community detection analysis. So the number that is shown for modularity is the maximum coming out of 10 runs, and it gives me two communities. And here is the community detection algorithm used for this purpose. This is for community detection, and the communities will be used to color code the follower network, which is visualized. So if I go back to visualizer now, I will be able to visualize the follower network which I formed. So this time I choose the file along with the analytics, which is a JSON file, and also the second aspect that I can add to my network is the level of importance of nodes. The level of importance is introduced through three major metrics in this program: page rank, hubs, or authorities. So I select them, one of them, and then I'm good to go for visualizing. The job is done, and when I view it, here is the network as seen. Three major colors: blue, green, and red. The ego is in a different color, and each color is showing one of the communities of this network. So this is what it looks like in a small network. When it comes to the more sophisticated and larger networks, things get a little bit messy. So here is just a snapshot of a portion of the network for crosstown project. That's why this program has the capability of exporting these files into more capable visualizers. To be used in the case of more complicated networks. So the question is, where do the level of importance come from? Where does the page rank or hubs or authorities are calculated? And then the answer is back in the analyzer. So in the analyzer, once we start the new job, apart from the community detection, the second aspect of the analyzer is to do the calculations for general network information. We just basically select the file and select the file, and then we run it, and the result of analysis gives us the general information regarding the network, along with the level of importance for each node in different measures that I just introduced. Here's the way that the output file looks like. So this is the output file for community detection. Each of the outputs have two different versions: a human readable version, which is just a text file, and a second version, which is a JSON file. And this is the same information in a different format used to retrieve the data or to visualize the networks. So the other thing is the other output is level of importance, which are given for different nodes as different numerical values, either in the text format. As you see, it shows what is the level of importance of each node in using PageRank as the measure, and here's the value. The same thing for hits, and the same thing for authority. And the other format is the JSON format, the exact same information, and as I said, machine readable format. So here are the main information coming out of a network, but the main target of this platform was to make a connection between the two sides of these social networks: the content communicated over Twitter and the analytics coming out of the social networks that we have in hand. This connection is formed in project discussion profiles. So let me get you back to the streamer and show you the format of what we get out of the streamer. So let's say there are certain keywords followed over time, and the information is stored in the database and is retrievable in a CSV format. As an example, this is one of those CSV format. As you see, the date in which a tweet is created, the Twitter ID for that tweet, which is the numerical code assigned to that specific tweet, and the screen name of the person who has created that tweet, and that tweet itself as a text are different for different parts of the CSV file. The CSV file can be retrieved by the user, and then the user can manually or through some classifiers, trained classifiers, can annotate this data and come up with something like this. This is the same CSV file, but in an annotated format. And the main semantic classes of interest in this specific case have been these four classes shown over here: the environmental, the economic, social, engineering, technical, and if a tweet had not belonged to any of these classes, it has been annotated as not. Again, this annotation can happen either manually through human coding or through automated trained classifiers. Well, basically, this CSV file can be returned back into our platform. So our platform in the analyzer menu can, through the key which is shown here, can create the PDPs by reading that CSV file. So I select the CSV file, and on the other side I select the information. I have to import the information regarding the social network behind that CSV file, which includes the communities and the network itself. So I introduce the network, introduce its communities, and I introduce the CSV file which gives the tweets by these people. And at the end, the program asks me to select an output a name for the output file, and then it creates the project discussion profiles, either as a compilation of all discussion among all nodes of the network, or in a community-based format. So if I change this false into a true, then the project discussion profile which is generated is a community-based. It gives me the discussion for each of the communities in separation. So let's show you what the output looks like once I give the CSV file and all the information and run it. Yeah, after running, here is what I get. This is the way that the output looks like. So what is shown here gives me those, well, it's given in the environmental semantic class, and it's giving me the output based on the communities for positive sum, negative sum, and summation of all the weights for all the discussions. When aggregating multiple snapshots of the same network, we will get multiple reports in each of the semantic classes. We can aggregate them together and come up with a report like this. As seen, for each of the semantic classes, including environmental, economic, and if I scroll down, the other classes, including the social and engineering, technological, and none will pop up. And as you see, there are 16 or 18 different snapshots of this network which has been analyzed. Such a report can be imported into any visualizer for a CSV file, including Excel itself, and then the project discussion profile, or PDP, can be visualized like what's seen here. So each color shows one of the semantic class values here. Importance of this positive sentiment, negative sentiment from